So this is a Chapter 9 bonus section on even and odd functions. So the graph of an equation is symmetric with respect to the x-axis if the replacement of y with negative y results in an equivalent equation, i.e. I can fold my graph in half along the x-axis and the graph would meet up. A graph is symmetric to the y-axis, much like this parabola, right? If I can replace x with negative x at the same, and I get the same results, right? I could fold this graph up along the y-axis and the graph would overlap. We also call this an even function. So I said an example of an even function is y equals x squared. So if I have y equals negative 2 squared, that means y is 4. And if I have y equals 2 squared, y is 4, right? It's symmetric. And I said that if I replace x with a negative x, we get a equivalent equation. Here we got equivalent values. Let me show you how to find equivalent equations. Another example of symmetry is symmetry about the origin. So I could rotate it 180 degrees and it would look the exact same. Functions that are symmetric about the origin, like for example, this is y equals x cubed, are called odd. So even functions are symmetric across the y-axis, and odd functions are symmetric about the origin. So the graph of an equation is symmetric with respect to the origin, or odd, if the replacement of both x with negative x and y with negative y result in the same equation. So let's substitute in negative x for x and negative y for y and see if we get an equivalent equation. Negative x squared plus negative y squared is 16. That means x squared plus y squared is 16. We get the exact same equation. And that should make sense, right? This is a circle whose center is the origin and whose radius is 4, right? And if I was to rotate this whole circle, 180 degrees, it would look the exact same. So a circle with origin at the center is symmetric to the origin and is therefore an odd. But we wouldn't want to call it an odd function because a circle is not a function. So it is just symmetric with respect to the origin. Remember, in order to be a function, you have to pass the vertical line test. So the graph of an equation is symmetric with respect to the origin if when I change, again, like I said, x and y, I get the same equation. So let's test this. So this one, I have when x is, I substitute in x and y. So I've got negative y is negative x cubed. I get negative y is negative x cubed. Well, I could divide both sides by negative 1. So I get y equals x cubed. So not only is this symmetric with respect to the origin, we could say that this is an odd function because the graph of a cubic function looks kind of like this and does pass the vertical line test. So this would be an odd function, whereas a circle, even though it's symmetric with respect to the origin, would not be an odd function. So a function is even if when we change f of x for f of negative x, I get the exact same equation. And a symmetric is odd if when I substitute in negative x, I get negative f of x for all x in the domain of f. So a function need not be even or odd, it can be neither. So let's go ahead and substitute negative x. So if I have f of x, in order to determine if this function is even, odd, or neither, I'm trying to determine if this function is even, odd, or neither. So I have 8 negative x to the 4th minus 3 negative x squared plus 1. I get f of x equals 8x to the 4th minus 3x squared plus 1. These are identical, so this is an even function. Let's try this again. If I have f of x equals 6x squared minus 9, I'm going to substitute in negative x, and then I'm going to look at my result to determine whether my function is even or odd. So I have f of negative x equals 6 times negative x cubed minus 9 times negative x. So I have f of negative x equals negative 6x cubed plus 9x. Notice that this is negative f of x. If I put a negative in front of my f of x, I'd get negative 6x cubed plus 9x. So this is an odd function. If I have f of x is 3x squared plus 5x, and I want to determine if it's even, odd, or neither, I'm going to substitute in negative x and see my result. So I have f of negative x is 3 negative x squared plus 5. So f of negative x is 3x squared minus, sorry, I have to substitute in negative x squared as well, minus 5x. Well, f of negative x doesn't look the same as f of x, so it's not even. It also doesn't look the same as negative f of x. Negative f of x would have been negative 3x squared plus 5x. So this is neither even or odd, meaning it's not symmetric to the y-axis or symmetric to the origin.